When we look at the structures in space, asteroids are perhaps among the most overlooked objects. Yet when we dig into their origins and examine what they contain, we begin to realize how important and valuable these rocky bodies truly are. Today, we will explore the origins of asteroids, why they are actually so important, and what kind of resources they may represent for our future. Before we begin the video, don't forget to support me by subscribing to the channel, liking the video to help it reach more people, and sharing your ideas for future videos in the comments. Now, if you're ready, let's take a deep look at one of the most overlooked objects in space, asteroids. Asteroids are, so to speak, the silent but oldest witnesses of the solar system. When we look at the planets, moons, and other structures in space today, we see an orderly and settled system. However, behind this apparent order lies a chaotic birth process that took place billions of years ago. The asteroids we are talking about in today's video are essentially frozen remnants of that chaos. Around 4.6 billion years ago, the solar system began to form when a massive cloud of gas and dust collapsed under its own gravity. During this collapse, the sun was born at the center, while countless small pieces of rock, ice, and metal formed within the rotating disk around it. These fragments interacted with one another, collided, and merged. Over time, these growing structures eventually became the planets we know today. However, this process did not occur uniformly everywhere. In some regions, collisions and mergers were stable enough for planets to form, while in other regions the process was interrupted, leaving behind countless rocky fragments drifting through space. One of the most notable of these regions is the area between Mars and Jupiter, known today as the asteroid belt. This region became a graveyard of failed planet formation. The primary reason for this failure was Jupiter's enormous mass. Jupiter's powerful gravitational influence prevented a planet from forming in this region by constantly disturbing, disrupting, and fragmenting any growing bodies. Jupiter acted almost like an invasive force, destabilizing and destroying any structure that attempted to grow nearby. And although no planet formed there, some asteroids in this region can still be extremely large, some even approaching the size of Pluto. However, size alone is not enough for an object to be classified as a planet. No matter how large a body is, if it does not meet certain criteria, it cannot be considered a planet. That is why even the massive objects within the asteroid belt are not classified as planets. These large asteroids did not form all at once either. Instead, they gradually emerged as millions of smaller objects left behind by Jupiter's gravitational disruption slowly merged over time, forming the asteroids we observe today. Many people think of asteroids as being limited only to the asteroid belt, but asteroids are not confined to this region. They exist throughout different parts of the solar system, including objects whose orbits even cross Earth's path. These are known as near-Earth asteroids, and they are of great importance both scientifically and in terms of planetary defense. For a long time, scientists believed asteroids were solid, single-piece blocks of rock. However, recent observations and analyses have completely changed this view. Measurements of gravitational interactions made possible by spacecraft visits have played a crucial role in reshaping our understanding. As a result, we now know that many asteroids are actually what scientists call rubble piles. These asteroids are not solid bodies but loose collections of debris formed after massive collisions in the past. Although they were shattered, they did not fully disperse and instead reassembled under their own weak gravity. Because of this, their internal structures may not be solid rock as once thought, but rather porous and sponge-like. Some scientists even suggest that many asteroids may be largely hollow inside, almost like an eggshell. This idea dramatically changes our understanding of what would happen if an asteroid were to collide with Earth. The damage caused by a solid, dense asteroid would be vastly different from that caused by a porous or hollow one, meaning impact scenarios can vary far more than we once believed. The chemical composition of asteroids is just as surprising and unexpected as their physical structure. Some are rich in carbon, others are dominated by silicates, and some are composed almost entirely of metal. Metallic asteroids in particular excite scientists because, according to some theories, they may be the exposed cores of early protoplanets that were once forming but were later destroyed. In other words, they could be remnants of objects that nearly became planets. If this theory is correct, it could fundamentally change many of our ideas about the early solar system and force us to re-examine its history from the ground up. Even more fascinating is the fact that some asteroids are rich in organic molecules and water-bearing minerals. This has led scientists to ask a profound question. If asteroids contain organic compounds and water, could life on Earth have originated from asteroids? According to many scientists today, this idea is highly plausible. Earth experienced intense asteroid bombardment during its early history, and the minerals and water delivered by these impacts may have played a key role in the emergence of life. Beyond helping us understand the past, asteroids also show us how dynamic and ever-changing the solar system still is today. I don't know if you've ever heard this before, but some asteroids actually have their own moons. Yes, you heard that right. For example, one of the most famous asteroid moon systems in our solar system is Didymos and Dimorphos. The main asteroid is Didymos, with a diameter of about 780 meters, while its moon, Dimorphos, is roughly 160 meters across. What makes these asteroids so famous is that they hosted humanity's very first deliberate planetary defense experiment. In 2022, NASA carried out a mission called DART, intentionally crashing a spacecraft into Dimorphos. The goal of this impact was to change Dimorphos's orbit and to answer one crucial question: how can we protect our planet before a potential collision occurs? Quite surprisingly, the experiment was successful, and the orbit of this small moon was changed by a measurable amount. This success gave scientists an incredibly important clue about what humanity might be capable of doing in a real future threat scenario. One of the most striking discoveries about asteroids is that some of them have tails. For many years, we believed this was a feature exclusive to comets, but now we know that certain asteroids can also release material from their surfaces, creating tail-like structures. This shows us that the distinction between asteroids and comets is not as clear as we once thought. After all, comets are also made of rocky material just like asteroids. Additionally, I should mention that recent observations by the James Webb Space Telescope have revealed something even more unexpected. Objects we never imagined could have tails actually do. For example, astronomers have discovered a real star with a tail. I emphasize real star because this object is similar to our Sun. Another fascinating example is the discovery of a tailed exoplanet. This distant planet, as it orbits its star, slowly loses parts of its atmosphere, leaving a tail behind it. Being able to detect this tail and identify it as atmospheric escape has significantly changed what we know and what we think about the relationship between planets and their atmospheres. As we've said, we can no longer easily distinguish between comets and tailed asteroids. In fact, there are some objects that we can't clearly classify as either a comet or an asteroid. One of the most famous examples is Oumuamua. This object came from interstellar space, passed through our solar system, and then continued on its way. Scientists still cannot fully place objects like this into a single category, and their origins remain a mystery. As the years have passed and our experience and knowledge of space have grown, humanity hasn't been content with simply observing asteroids from afar. We sent spacecraft to them, conducted research on their surfaces, and in some missions we even collected samples and brought them back to Earth for detailed analysis. Thanks to missions such as Hayabusa, Hayabusa 2, and OSIRIS-REx, we can directly study the composition of asteroids here on Earth. Using these samples, we try to understand what happened during the early periods of our solar system and our planet. More specifically, we attempt to uncover the chemical conditions that existed at that time. Some people argue that studying asteroid samples is meaningless and that we cannot learn about the past this way, but this idea is quite absurd. Under normal circumstances, Earth would not contain many of the molecules we find today, but through asteroid impacts, these molecules were delivered to our planet. As I mentioned earlier, it is even believed that Earth's water and organic molecules originated from asteroids. The asteroids we've discovered that contain large amounts of water and organic compounds on their surfaces are the clearest evidence of this. Another major goal of asteroid missions is to pave the way for asteroid mining. Asteroids can be extremely rich in rare metals, water, and materials that could be used as fuel. As you know, these resources are essential for space travel and for establishing colonies beyond Earth. Without them, humanity cannot maintain a permanent presence in space. We would simply travel from Earth and return back again. The planned bases on the Moon are one of the best examples of this idea. Space agencies that aim to go to Mars are trying many different methods to make the journey easier and reduce costs. At this point, it has become clear that building a base on the Moon is the most logical solution. And when I say base, don't imagine something small. This will be a massive, large-scale facility. Scientists and governments plan to use this base as a temporary stopover for astronauts and space travelers before they continue their journeys. Most likely, all necessary resources will be transported there at first, and eventually, production will even take place on site. Over time, this base could reach a level where it sustains itself without needing supplies from Earth. Asteroid mining, in this sense, would be a more portable and faster version of the same idea. In the future, for crewed missions to more distant regions and as new resources are needed to replace those depleted on Earth, specific asteroids will be selected. These asteroids will be mined, and once sufficient resources are collected, they will be brought back to Earth. While this may sound like science fiction to many people, I can honestly say that this is one of the easiest things we could realistically achieve with current or near-future technology. Finally, throughout history, Asteroids have played a crucial role in shaping both Earth's geography and the evolution of life itself. The impact that led to the extinction of the dinosaurs is one of the most dramatic examples of this. However, asteroids are not merely objects of destruction, they also play a key role in planetary evolution, the emergence of life, and our efforts to understand the universe. In fact, if it weren't for them, Earth might not even have oceans. Humanity might never have existed at all. That's why viewing asteroids only as threats would be one of our greatest mistakes. They are carriers of the past and at the same time keys to the future. So there you have it, my friends. Asteroids are among the most overlooked, yet most important members of this system. Like everything else in the universe, we, and those like us, must recognize their value and ensure they receive the importance they deserve. That's all from me for today. If you'd like to support me, don't forget to subscribe to my channel, like my videos, and share your thoughts in the comments. Until we meet again in our next video, take good care of yourselves. Goodbye.